Hello my dear students. Today we are taking a topic fluid mechanics. Fluid mechanics, two words. First word is fluid and second word is mechanics. So what is the meaning of fluid? So firstly we know about what is the fluid. Fluid which can flow is called fluid. What is that which can flow? Okay? That which can flow is called fluid. Basically fluids are two types. First one is liquid and gases. Liquids and gases. But in this chapter we taking only liquids. We study about liquids in this chapter. Okay? Now, and next word is mechanics. What is the meaning of mechanics? Well, liquid at rest. So this is statics. So we can say that fluid statics. Okay? And the similar, when liquid in motion. When liquid in motion, so the study is kinematics and dynamics. Okay? This is the about which we are taking in this chapter. And the next we taking a liquid, ideal liquid. Okay? And the ideal liquid is always incompressible and non-viscous. Okay? The first, this is a liquid like that. This is liquid particles. This is the liquid particles. Okay? The density of liquid is rho. Okay? And the next one is, if we taking a ideal liquid. Okay? We taking only ideal liquid. The property of ideal liquid is it should be incompressible as well as non-viscous. So what is the meaning of incompressible? The force between the particles, we can say that the particles of liquids, they are not compress each other. That's why we are taking incompressible. And similar, what is the non-viscous? The particles of two adjacent layer. This is the first layer and this is the second layer. The particle of liquid, there is no friction between the two particles, the two adjacent layer of liquid. It is also non-viscous. Though the first point we are taking is liquid we deal with incompressible and non-viscous. Okay? This is the first point. And the second point, the first point, we taking ideal fluid. And the ideal fluid properties is incompressible and non-viscous. What is the meaning of non-viscous? There is no friction between the two adjacent layers of liquid. So write down, there is no friction, between two adjacent layers of liquid. Okay, and the third point about the density. Density is remain constant and independent variation in pressure. Okay, so the next point is the density of liquid is independent the variation in pressure, okay, and always remains constant. Okay, this is the third point about the ideal fluid, and the fourth point is only force exerted by one particle of liquid on other particle of liquid between the contact. This is the contact between the particles, and the force exerted always perpendicular to the surface in contact. This is the condition we are taking in ideal liquid. So the write down the force exert by one particle of liquid on other particle is perpendicular to the surface in contact, to the surface in contact. Okay, so this is the talking about the fluid, and fluid, which fluid? Liquids. And which liquid? Ideal liquid. So these are the condition we are taking in this chapter. The next topic is fluid properties. So write down the fluid properties. Okay, the next topic is fluid properties. The first property of fluid is mass density या density. तो write down mass density or density. The mass density, the symbol we use rho, and rho is equal to mass of a substance upon volume of substance. This is the mass upon volume. This is m by v. And what is the unit? Unit of density, SI unit of density is kilogram per meter cube. Okay, and the definition of mass density of a liquid is the mass which it possesses per unit volume. So write down the mass density of a liquid is the mass which it possesses per unit volume. Okay, it's called mass density. This is the mass density. This is the first property of liquid. And the next property is relative density. What is the relative density? The density of a substance with respect to the other substance. To write down the next property of fluid is relative density. Relative density. And the relative density is equal to density of substance divided by density of pure water at 4 degrees centigrade. This is the relative density, and this quantity is unitless. Why? Because it's also density and this also density, and the density divided by density is kilogram per meter cube divided by kilogram per meter cube is 1. So we can say that this is the unitless quantity. So what is the definition is it is defined as the ratio of density of substance with respect to the other substance at 4 degrees centigrade. This is the relative density. This is the second property of fluid. The third property of fluid is specific weight density. To write down the next one is specific weight or weight density. Property number third. Specific weight or weight density. Okay, it is the specific weight denoted by small w. This is equal to weight per volume. What is the weight? This is equal to m into z and divide by volume. We know that mass upon volume is mass density. This is rho. So now we can say that the specific weight is equal to rho g. Okay. So now what is the definition? It is defined as the ratio of weight of substance to the volume. Okay, this is the specific weight. Okay, the next property is specific gravity. So write down the next property, specific gravity. What is the specific gravity? Specific gravity is denoted by S is equal to specific weight of a given substance divided by specific weight of pure water at 4 degrees centigrade. What? Specific weight of given substance divided by specific weight of pure water at 4 degrees centigrade. This is the specific gravity. Now, what is the specific weight of a substance? This is the rho g, and this is the rho g. This is S is equal to rho into g. This is the liquid. Substance is liquid upon density of pure water into g. G and g cancel out, and the ratio of rho L by rho water. This is the same ratio of relative density. Okay? This is the specific gravity. This is the fourth property of fluid. And the next property is pressure. Pressure of the liquid. So next topic is pressure. What is the pressure? Pressure is like this. This is the vessel. A liquid is fed in this vessel like that. This is the water. With taking a very small area like this. This is the delta S. Okay? And the force exerted on this area. Okay? So now the pressure P is equal to force divided by area, and the area is tends to 0. So now we can write down this is dF by ds. Okay? This is the pressure. So we can say that pressure is equal to force per area. So the definition of pressure is pressure may be defined as force exert on a liquid per unit volume, per unit area. Okay, this is the pressure. Pressure may be defined as force exert on liquid per unit area. It's called pressure. Okay, this is the pressure. What is the unit of pressure? Unit of pressure is, the unit of force is Newton, and the area is meter square. So what is the unit of pressure is Newton per meter square. So write down. Now SI unit of pressure is Newton divided by meter square, and the similar this unit we can say that Pascal or PA. Pascal will represent PA. Okay, this is now the pressure when variation in depth. So what the pressure will be changed, how much pressure will be changed. So the next topic is variation in pressure variation in pressure with height, variation in pressure with height. This is the next topic. Okay, now this is the vessel. This is the vessel. Okay. Like that. And the liquid is fed in this vessel, and this is the area we taking. This is the delta S2, and this is the liquid is like that. Okay, and this is the area, and this is also area. Okay, and the difference between these areas is dz, है ना? How much? This is dz, and this area is delta S2, and this is S1, and the similar okay. So now variation in pressure with height. So in this point and the depth, yeah, we can say that height in downward direction, this is dz. So how much change in pressure? So we are show in this topic. Okay, now firstly we consider delta S1 is equal to delta S2 is equal to delta S. Okay, and the next, this is the force exerted, this is F2, and force exerted on this area, this is F1. So now P1 is equal to force divided by area. Yeah, we can say that force is equal to pressure into area. So the pressure we consider at that point, this is the P, and the area is delta S1, and S1 is equal to delta S. This is equation number 1. Similar, the force F2, we consider some change in this pressure. This is the dP. So now the pressure will be changed is P dP, and the area is delta S2 is equal to delta S. This is the equation number 2. Now, what is the volume? What is the volume? The volume is dz, area into height. This is the volume. And what is the weight of liquid? Mass into g. This is the mg, and the mass is equal to density into volume. Density of liquid is rho, and the volume we are use equation number 3. This is delta S dz and into dg. This is the equation number 4. Now the force balance in vertical directions. Now we balance the force in vertical direction because the liquid is equilibrium in a vertical direction. So now for vertical equilibrium. Now for vertical equilibrium, forces are balanced. So now this is the upward direction force is F1, and this is equal to downward direction F2 plus weight also in the downward direction. This is equal to F2 plus weight. Now the value you put in this equation number 5, F1 from the equation number 1, this is P delta S is equal to, what is the F2? P plus dP. This is also delta S. And what is the weight from the equation number 4? This is rho delta S dz into G. Okay, now delta S and delta S are cancelled out. All the equations, the remaining equation is P plus dP plus rho dzg. Now P and P is cancelled out, and the remaining term is P is equal to minus rho g dz. This is the variation in pressure, how much. This is equation number 6. Now we integration in both the sides. This is the dP from P1 to P2, and the similar minus rho g dz from the height from 0 to z. The pressure will be, what is we taking the limits, the integration of dP is P. This is the P2 minus P1 is equal to rho g constant. This is the outside from the integration, and the integration of dz is z, and we put the limits, and this is the z. So now we can say that from equation number 7, if we from the equation number 7 we can write down how much pressure will be changed in the heights. So now P1 is equal to P2 plus rho g z. This is the equation number 8. So now we can say that if we in the depth height z, so how much pressure will be increased? Rho g z. Okay. Okay. The next one is, if we taking about, this is the cylinder. The area, this is S1, this is area S2. This is the point A, and this is point B. Now the force exerted F1, and this is F2. Now similar, in this condition, delta S1 is equal to delta S2 is equal to delta S. This is equation number 1. Now what is the pressure at A point? The pressure at A point is force into area. This is F1 delta S1. Delta S1 is equal to delta S. This is equation number 2. Similar, P2 is equal to, or this is the direction of this is F1 is equal to P1 delta S. This is equation, this the direction of force is in a forward direction, this direction. This is equation number 1. And similar, the F2 is force into area. This is P2, and this is delta S2 is equal to delta S, and this is the direction in backward direction. This is equation number 2. From the equation number 1, if we balance in horizontal directions, so we can write down for horizontal equilibrium. What happening? Force are balanced. F1 is equal to F2, So now P1 delta S is equal to P2 at delta S. So now we can say that P1 is equal to P2. So we can say that when any liquid a pressure is same at 2 points are in same horizontal level. If 2 points are in this vessel at same horizontal level, so we can say that the pressure will be same. The next topic is Pascal law. So now write down the Pascal law. Pascal's law. What is the Pascal law? This one, and this is like that. Okay, this is the piston, and this is also piston. This is the 1A position, and this is the B position, and in this the weight of car is like that. This is the car at this piston, and this is the F1 is exit at position A, and F2 is exit. Now we can say that F2 it exits at position B, and the area of this A is A1, and the area of this piston B is A2. Okay. According to the Pascal law, when this is the liquid is fed in this hydraulic lift. This is the hydraulic lift. This is the hydraulic lift. This diagram is hydraulic lift. This is hydraulic lift. Okay. So we can very easily understand by the Pascal law. According to the Pascal law, the pressure exert at any point on liquid is equally distributed in all directions. Okay? So according to Pascal law, the pressure exerted at any point on a liquid is equally distributed in all directions. Okay? So now we can say that the pressure at point A is P1. P1 is equal to F1 is equal to A1. This is equation number 1. And the pressure as point B is F2 upon area. The pressure P2 is equal to F2 upon A2. Equation number 2. Now, from equation number 1, equation number 2, and according to Pascal law, the pressure exerted at any point on the liquid is equally distributed in all directions. So we can say that P1 is equal to P2 according to Pascal law. So now we can say that A1 is equal to F2 upon A2. Okay? This is the law of Pascal. And also the Pascal said, the second statement of Pascal is when same point at a liquid, pressure will be same. So according to the second statement is, this is the first and the second statement according to the Pascal law. The pressure same at 2 point, the pressure at 2 same at 2 point in the liquid at same, the pressure same at 2 point in the liquid, the pressure same at 2 point in the liquid at same horizontal level, same at horizontal level. The pressure same at 2 point in the liquid at same horizontal level. Okay? So now at point A pressure equal to at point B pressure. Okay? This is also the statement of Pascal law. Based on this Pascal law, now we solve a question 1. Okay? This is the question. According to this question, the diagram is same. The small piston diameter is given, this is equal to 5 centimeter, and the diameter of bigger piston is equal to 20 centimeter, and the F1 is given 5 Newton. So we have to find out the force F2. So now we know that according to Pascal law, the question is this. This is the question. This is the question. The small piston diameter is 5 centimeter, bigger piston diameter is 20 centimeter, and the F1 is equal to 5 Newton. So we have to find out the force F2. What is the F2 is? So now the solution of this question is, we know that pressure at point A is equal to pressure at point B. This ठीक है? तो P1 is equal to P2. This is F1 upon A1 is equal to F2 upon A2. Now we put the value. F1 we have already know, and the area of this cross section area is, what is A1? A1 is equal to pi by 4 d square, and this is the pi by 4 d square is 5 into 10 की power minus 2 whole square. This is the A1. Similar, the A2 is pi by 4 capital D square, and this is equal to pi by 4. The diameter of the bigger piston is 20 into 10 की power minus 2 whole square. Now the value we put A1, this is the pi by 4 into 5 into 10 की power minus 2 whole square is equal to, we have to find out F2. This is pi by 4 into 20 into 10 की power minus 2, and this is the whole square. Now this is cancel out. The term is remaining is 5, 25, F2, and this is 400. So now the value is F2 is equal to 5 into 400 divided by 25. This is the 5 times and this is the 8 times. So now the value is 80 Newton. Okay. So the force exerted on F2 is 80 Newton. I hope you understand the today lecture. Thank you very much.